Hello guys, what's up? So today we are going to solve first problem in the Leetcode May challenge, and the problem statement is like this. So first part was you have product manager blah blah blah. Unfortunately, the latest version of product fails since it was developed based on the previous version after is also bad. Okay. So you are given n versions 1 2 3 4. It's a continuous numbers. So you want to find out the first bad version which causes all the problem in the bad version. Okay, and we are given an API is bad version which we can use to find the whether a version is bad or not. Okay. So in the example below, as you can see, if n is 3 and my first 4 is bad, then the API is returning false for 3 but true for 4. Okay, and 5 will also be true. Okay, so how we can solve this problem is, let's say I have 1 2 3 4 5 6 versions, and so what I can do is I can start. So yeah, so the problem say if my bad version starts from here, let's say from 3, then all the subsequent versions will be bad. So this will also be bad, this will also be bad, if this is bad, right? So this will also be bad, right? And so, and before that will be good, right? So this will be good and this will also be good, right? So how we can do this is basically we can use the binary search here. So if I divide the number of integers, because the versions that are given will be in a sorted order, right? So we can definitely use binary search here to find the bad version. So for binary search, what we can do is we can first find the middle element, which is in this case 3. So if my 3 is a bad version, then it could be possible that 2 is also bad, like it started from 2. It could be possible. So I'll have to check whether my 2 is a bad or good. So if my 2 is a bad, then I can set my high equal to 2 and my low will be whatever my low was, right? So now my search space will be 1 and 2. And if my 3 is a good version, so let's take another case where my 3 is a good version, right? So let's say my bad version starts from here, and these are my bad, and before that is my all the good versions, right? So how will this take place is, so this will be good, right? So let's say there's a case like this. So now if I'll check for 3, which is the middle element, so initially my low is here and my high is here. So I check my middle element, which is 3. So if my middle element is a good version, which means the bad version could be m plus 1. So if my mid is a good version, then I'll basically check for m plus 1. If my m plus 1 is a bad version, then I can simply return m plus 1 because I have found my bad version. If it's not, then my low will be, then I basically need to search for the right space, right? So my low will become m plus 1 and my high will be same. So I'll be searching this space then, right? So let's write code for this. So since I am given my low and high as 1 comma m, so while, so I am doing my binary search here, low is less than equal to high, I'll basically calculate the mid value, which is low plus high divided by 2. So this is basically right bit shift, so this is equivalent to divide by 2, right? So if my mid is I am using the API that is given with bad version, I think it's bad version, yeah, it's bad version M, then I'll have to check for the left space, right, from where have this bad version started. So if my mid -1 is a good version, like mid -1 is a good version, then I can simply return M, because the defect has started from mid, right? If it's not the case, then I can set my high equal to mid -1, because then I need to search for the left space, left L. If my mid is not, that means the defect lies somewhere on the right side of the collection of versions. So now if it's bad version M+1, I can simply return M+1, else I'll have to check my log equal to M+1, right? So let's just try to submit it. Let's run the code first. So for this it's work, let's try to submit it. Accepted. Yeah, so this actually you don't need to care about, as long as you were able to solve the problem with the optimum algorithm. Thank you guys, thank you for watching.